Thank you, Eitan, for that. And now I'm really the last thing that stands between you and the startup pitches that are gonna come up next. So first time here at Restart AL, first time also here in this facility, so great to be here. My name is Lukas Oberhofer. I am the Managing Director of Starburst US. We're a global innovation catalyst, so a VC and accelerator with a pure focus on the aerospace and defense industry. And we have been partnering with II since many, many years, and are also powering this accelerator here, the II Catalyst program in the US. Yes, perfect. So, why is II doing all of this? And Eitan already explained to you a little bit, the bigger picture of how this fits into their strategy. But it's really for II to see around the curvature of the Earth, quite literally, to do two things. One, get technology access to US startups. And second, together with these US startups, create more US opportunities or US market access. More precisely, II wants to gain access to early stage deal flow, increase the brand awareness and be a thought leader, increase their visibility on frontier tech, and create a very long-standing pipeline for talent. And what you saw earlier and this really gives you a sense that II is not your typical prime that is really betting on mission-ready technologies, but much rather betting early on to gain a competitive edge for future technologies. So what do we do precisely? So basically, II Catalyst is a US-based, so we're based in Herndon, in Virginia, so very close to Washington, DC. Is a pre-seed and seed hybrid accelerator program that one, directly invests in startups, so it's basically 100K of cash investment, and another 100K of technology in-kind support. It's a 20-week program that ultimately leads to perform and develop a demo, and once proven, then to extend that into a larger pilot that can be a proof of concept, that can be a joint development, whatever the specific technology is about. And that's based on 3 distinct on-site elements, one at the beginning, one in the middle, and then one in the end. It's 3 to 6 startups that participate in each cohort, and it's embedded in around 100 dedicated experts, either mentors and other advisors. In terms of focal points or focus, it's really quite broad. So you see here a very broad set of technologies, AI autonomy, advanced materials, robotics, drones, so really across the different areas that II is working on. So how do we do this? It's really a hands-on, tailor-fit support to the individual needs and requirements of each startup. And that across 2 elements. One, the business side, and second, the technology side. So on the business side, we basically support the startups in general strategic guidance, business development support to address the US market, and fundraising support, obviously. And then on the technology side, it's really sitting down with the II technical people and really understand how this in-kind support can be played out or how a joint demo and pilot can be developed. So does this work? We strongly say yes. You saw the metrics before from Eitan, but ultimately what we're looking at here is we have performed now 2 full cohorts. The first one with 4 startups, the second one with 3, and now you actually hear from 4 startups today from our 3rd cohort. 75% of the startups continue to work with, continue to be engaged with II outside of the accelerator. We have 10 signed MOUs, around $6 million raised in these first 2 cohorts. $2 million have actually been launched in terms of contracts or other financial grants from the Air Force in this case, or from other DoD members. So very strong set of metrics already in the first 1.5 years. So who do we have here? You see here all the cohorts, the 12 startups in total, split from cohort 1 and 2. And then specifically here today, we have 4 startups from cohort number 3. Augsense, that is going to focus on wearable technology. Dalion on a revolutionary electric propulsion system. Rhea, focused on reliable navigation. And then also Omira on the communication side. So with that, I'd like to welcome the startups here to the stage, and we can kick off the presentation and pitching.
So thanks for bringing us over. Very excited to present you Dalion. I'm Roderick. I'm the CEO and co-founder of Dalion. And what we're working on is basically a completely electric new propulsion system. We are in stealth. I had to convince my co-founders to go here and present for a large audience because we're definitely not shouting off the roofs that we're doing this, because we think that we're sitting on something very special. And you will see our prototype that is flying without moving parts, no emissions, and completely silent. So imagine a world where flight is silent and we have endless capabilities to send ISRs into the sky, for example, that you don't hear and there's no emission. The biggest problem in the drone space is obviously, it's here on the slide, acoustic signature threat. What means you see it coming and you can do something about it. You want this drone to be completely silent, obviously. Emissions has always been a very big problem in the aviation space. We are focusing on drones, but the second phase, we're obviously also looking into urban aviation, and you will see that on a later slide. Limited endurance, obviously anything mechanical with propellers or combustion engines is known to break. Therefore, Teslas have a better endurance, for example, because it's fully electric. And our propulsion system is fully electric. I hear you thinking, well, a drone is also electric, but it still has a propeller, right? And it still has a magnet into the motor. And all those things is not something that you find in our technology. Regulatory pressure is also known to everybody. Obviously, we need to do something about it. And flying electric is not a matter of if, it's more a matter of when. And we're working hard to make that a reality. So the breakthrough that we found, maybe you are familiar with the ionic wind technologies that NASA and MIT have been working on already since the 40s, I think. And I think the first experiments were happening in Russia in the 1920s. We found something to really make a strong electric propulsion system and thruster that you will see flying later up in the presentation. So near zero noise, no emissions, no moving parts. We're very excited about that. So the projection for our P2 performance, you see a slide here that shows a propeller aircraft, a jet, the MIT thruster that you might have seen on YouTube. In 2018, MIT had a thruster technology as well. Well, we think that we can really boost that with our technology to fly fully electric. You see the Dalion P1 that will be in, I have to speed up here. The Dalion P1 is actually the prototype that you will see on the slide here. And we break the voltage efficiency barrier and the electromechanical issues that you find in ionic wind propulsion systems. Result is a stronger airplane or a drone. Silent, less propellant, sustainable electric, and low maintenance. Why now? Obviously, there's a need for aviation and drone technology, and there's a huge addressable market that we want to address. We want to manufacture our own drones here in the US and elsewhere in the world. Obviously, the accelerator program and IAI is a big help and helps us get to the next level and the next prototypes. Hardware innovation is at a scale and a level at the moment that has never been seen before, 1 minute. And there's a global demand for quiet and green innovation. I'm going to slip through this. The focus, the second focus is more on the urban aviation. We're not thinking about to replace a Boeing with 300 people, but urban aviation with our technology should be a possibility in the near future. Product roadmap, I'll spare you that as well. We're working on the second generation prototype that will deliver the capabilities that you saw on the previous slide, but that will fly, again, fully electric, no moving parts. We want to team up with partners to license our technology, but also make our own products. We have designs for drones in the ISR space, so intelligence, surveillance, and reconnaissance. to really kind of start there and move the technology to the next level. Traction and validation. We raised $1 million in funding. We think about raising our seed round in October when we have our next generation prototype ready. We have the patent spending time is up, but this is the team, and this is the flying object. So this thing is now flying with no moving parts, and it is also known as the flying box within IAI. They say, hey, this is the flying box company because this thing is flying. You see a ZEPI tower there in the middle. It is connected to 40,000 volts. But as you can see, there is no propeller, there's no combustion engine, and so forth. So this is Dalion. Anybody that is interested to talk more, we're raising capital, and we're getting ready for the next step. So hope to see you after the session. Thank you.
Thanks, Roderick. Maybe just one question. Maybe you can dive a little bit more into the fundraise and how much you're raising and what the next steps are.
Yeah, so we raised capital. We raised capital from IAI. The royal family in the Netherlands came in as well. We have raised $1 million so far in SAFE agreements. So a typical Y Combinator setup. We're a typical startup. I've done startups before, Dalion as well, and we try to be as vanilla from a financing point of view as possible. Yeah, the seed round is due for October. We want to raise around $15 million to get to the next level, start production, American dynamism of drones, and get to the next level of the company.
Thanks, Roderick.
Thank you.
So coming up next, we have Bryce from Augsense. Take it away, 5 minutes.
Good morning. My name is Bryce Randle. I'm with Augsense. Augsense is a sensor fusion company. Our vision is ambient computing. We're looking to better understand what's happening inside the body, in the environment, and to control computing devices. Before I jump into it too much, though, I'm going to tell you a little bit of a story. A friend of mine is a pilot, former Navy commander, and he worked a full day. Was ordered to go on a mission. Took 5.5+ hours to get to that mission. The mission took 3+ hours to execute, and on the 5.5-hour journey back, he fell asleep with 20+ soldiers on board. They did not crash, but it required his co-pilot to bring him to. The fact of the matter is he was tired. He was fatigued. Where we are today is that survivability and operational readiness is paramount. Whether it is tiredness and fatigue, musculoskeletal injuries, chemical, biological agents in the atmosphere, or explosions and blasts that cause concussions or traumatic brain injury, the most invaluable asset that we have is the soldier. It is the warfighter. And not being operationally ready, it costs the military about $2.25 billion per year. Therein lies the beast. The beast is the most advanced biometric and environmentally sensing wearable ever. It takes all of the vitals and biometrics in the body. We're talking brain waves, core body temperature, and all the normal blood pressure, heart rate, speech recognition, and overlays that with the environment. Operational blasts, chemical, biological, radiation in the atmosphere, and gives you an understanding of how those consequences in the environment affect the body. On-edge computing, real-time AI, generative AI feedback, no radio frequencies. Most important part, no cloud, no internet. How did we get here? We only conceptualized the beast in February of this year. We moved very quickly. We were accepted into the cohort in June. We started development in July. We will deliver our MVP next month. We're moving very quickly. It's important also to note that we've done our homework on the opportunity. So we scoured the 2026 fiscal year budget. and identified $1.6 billion immediately and directly applicable to the beast. We're underpinning that with our efforts and relationships with the likes of primes, Space, IAI, Northrop Grumman, and also the program offices within the DoD. That $1.6 billion quickly grows into 5 with respect to the re-up year over year. But it is a dual-use product, all right? So when we go into the commercial side, we're talking about everyone from firefighters to Formula One drivers. I spoke with someone about NFL today, all applicable. But the ambient computing market at $51 billion has a 25% compounded annual growth rate that we can capitalize on. That's $172 billion in the next 10 years. My background is oil and gas, offshore, high stakes, high consequences of failure. I understand and have experienced extreme exposure. And the pilot I told you about, his name's Stephen Jones, former Navy commander. He's our VP of development, underpinning our relationships in the United States Special Operations Command. And that's why we're asking for a $2 million investment. We've already taken in about $500,000, but this ask, which will commence after the MVP is done, gives us our 18-month runway so we can execute 4 pilots, accelerate and deliver our CBNRE component, of which the explosive component is already underway, and secure approximately $3 million in revenue. Now is the time, because Special Operation Forces teams are being reduced. They're smaller, but the cognitive load and responsibilities being placed on them is higher. That's where the beast comes in. Local LLM, local processing, and as I mentioned, our team is delivering hardware at the speed of sound, at the speed of software. We can't go that fast, though, too. So, Augsense, sensor fusion. We're looking to protect lives, improve human performance, and be the next generation of ambient computing. Thank you.
Thank you, Bryce, for that. Can you elaborate a little bit more on the regulatory ecosystem, specifically FDA, of your product?
Yeah, good question. We're just going to steer away from the FDA. So we are not a medical device. As of right now, we don't intend to be a medical device. However, we're looking to provide as much information as possible so that diagnosis can be done extremely quickly and more efficiently. So think Combat Medic in a multi-casualty triage scenario. They'll have historical data and live data real time on those vitals to eliminate maybe having to do some of those tests to figure out what's going on.
Thank you.
Thank you.
So coming up next, we have Matt from Rhea Space Activity.
Hello, everyone. It is very nice to be here today. I'd like to thank IAI and Starburst for inviting us to this wonderful event. My name is Dr. Matthew Gorban, and I'm a theoretical physicist with Rhea Space Activity. Rhea Space Activity is developing cutting-edge GPS-denied navigation technology and the world's most advanced star trackers. Our CEO, Sean Usman, unfortunately was unable to attend today. He sends his sincerest regards, but he started the company back in 2018 after he left the intelligence community, managing billion-dollar programs and developing the world's most advanced spy satellites during the Iraq and Afghanistan war. And when he started Rhea, he was approached by the US Space Force, and they asked him one very important and very difficult question. How do we navigate around the moon silently, autonomously, and without GPS? Now, this question has sparked years of R&D, and we've grown the team to 25 people. More than half of us have advanced degrees, a third of us have PhDs, and that's what led us to where we are today. We're developing GPS-denied navigation and advanced star tracking capabilities that are going to be putting us at the edge of what is possible in terms of navigation capabilities. Currently, GPS-denied navigation is one of the biggest hurdles that the military is facing today, not only in air, land, and sea, but also but around the world with commercial entities like planes and crafts. So for instance, commercial maritime vessels have been spoofed recently. Their GPS has been degraded and pirates have attacked them. Airlines have to take large routes outside of GPS-denied environments, costing them fuel and costing their customers a lot of time. We're a dual-use capability, not only addressing the imminent military concerns that face all of these domains, but also the vast commercial sector that requires sustained and reliable navigation capabilities. Like I said, we originally started in space. We can see here that we developed autonomous navigation capabilities, able to navigate in deep space without the need for GPS, using stars, celestial bodies, and even Earth-orbiting satellites. From there, we've advanced our technology and have now been applying it to hypersonic missiles, drones, maritime vessels, and even putting them onto camera phones for US Special Operations Forces. So they're ATAC devices equipped with an Android cell phone are able to provide them with GPS-denied navigation behind enemy lines, securing their operations and saving lives. We're currently working on integrating on mass market drone production. And these are, just so I know, these are all active contracts that we have with the US military. So I actually have colleagues right now down in Arizona integrating onto a US Air Force drone as we speak for a demonstration later this week. These are all very exciting opportunities, and we've secured a foothold in the US military market by addressing all of the different platforms and verticals that need and require GPS-denied navigation. Not only this, but we've also advanced star tracking capability by applying our proprietary algorithms in conjunction with hardware advances that allow us to produce the world's best star trackers. So our software algorithms are NASA-derived algorithms that we've commercialized and privatized that allow us to perform GPS-like navigation with only an upward-facing camera. We can get positional accuracies on the order of hundreds or even tens of meters, depending on the specs of your camera. And it goes even further than that. Not only are we developing out these algorithms, we are also pioneering curve sensing technology by having the world's leading expert in curved semiconductor technology join our team. This allows us to create even more advanced cameras that improve image quality by 70% and also lower the size, weight, and power of your system by up to 45%. Not only does this make better cameras that allows us to do more improved sensing, but it also means that our star tracking technology in a domain where mass is a huge requirement can be smaller than ever and more performant. So for instance here, I have a comparison between Aerospace activity star tracking technology and those of our competitors. Not only are we more accurate due to the fact that we're using these curved sensors, but we're able to operate at higher refresh rates and at higher rotation rates than ever before, unlocking new maneuvers that satellites were previously incapable of doing due to limitations of even the best commercially available star trackers. Now, this is an incredibly exciting time for Aerospace activity and for investors in the audience. We are currently at our product market fit. We are finishing up $9 million worth of contracts this year and are expecting 14 times more contracts next year. We are currently in talks with the US Air Force and US Space Force to develop out our GPS-denied navigation technology for thousands of drones. And we need this money in order to secure up production and enable quality and reliable navigation, not only for military customers, but for the commercial entities as well. So thank you very much for your time.
Thank you, Matt. Can you share a little bit more details on what it means to be integrated into a platform?
Yeah, absolutely. So perhaps the biggest advantage of our system is we are primarily a software-based algorithm. All one needs is an upward-facing camera affixed to their platform, and we can provide you with GPS-like navigation, like I said, down to hundreds or even tens of meters. For instance, for our drone platform, we're affixing a camera to the top of the hull, and we're able to look upwards, and then now we can see the open sky, see stars, satellites, celestial bodies, and we can perform navigation at night and over domains where other alternative P&T sources fail, like open waters, which is somewhere where is incredibly important, especially in the Indo-PACOM region and near littoral environments at the coastlines, where no other GPS-denied navigation capability is able to work at the moment.
Thank you.
Thanks.
Last but definitely not least, we're talking about communications now with Jack from Omira. Take it away.
Hello, yeah, I'm Jack. I'm the founder of Omira Systems, and we are tackling the problem of communications in denied environment, as jamming efforts from our adversaries are becoming a bigger and bigger issue worldwide. So my background is in computer hardware engineering and startups, but when the war started in Ukraine in 2022, I went there, I joined the Ukrainian military. I served for over 2 years on the front lines as a drone pilot and electronic warfare officer, learning firsthand about the challenges on the battlefield. And most importantly, I got to study captured Russian electronic warfare equipment on the battlefield, which is an extremely rare opportunity. And I'm joined by my partner, Colonel Jeffrey Fisher, who is a retired Air Force electronic warfare officer with 7 combat tours, 2 Pentagon tours, and yeah. Why am I decided to tackle this problem of all of the things that I've seen on the battlefield? I got to work on countless systems, on drones, communications, precision artillery, and everything had the one problem in common, and that was electronic warfare and jamming. It was affecting everything on the battlefield. And also the way we and our allies we do warfare, combined arms warfare. You cannot do combined arms warfare if you cannot communicate and coordinate in real time between our troops, and that's why our adversaries invested in the technology that cut this communication. So I ended up developing a new software-defined radio that ditches everything you have known about military radio communication. We utilize the entire spectrum that it's available to us that doesn't require the line of sight. We utilize multiple channels in a parallel and redundant manner, but most importantly, our radio, it's aware of the spectrum around itself. It's aware of jamming efforts of our enemies, and we're picking the frequencies that we choose and how we move around the spectrum in an intelligent manner instead of just predefined frequency hopping. This is a subsystem component. We can sell this to anybody who needs to communicate on the battlefield. We can license the IP, or we're also considering building our own drones with this technology and having the only drones in the world that use RF and are able to fly and communicate in a denied environment. Quickly about our long-term plans, we don't want to build just an embedded radio and call it a day. So this is a Rodin system, and it's an AI-powered battle spectrum management solution that allows us to be aware of what is happening around us in the battlefield in real time, and to issue command and to take actions seamlessly in the battleground on the battlefield, allowing the warfighter to focus on their task and not to have to think about, is my radio going to work, or am I going to get jammed by my own guys, or anything like that. Where we stand in terms of traction, of course, IAI invested in us. That's why we are here. Taiwan wants to license our technology to integrate it into their systems, but not only that, they want us to come to Taipei and to build their entire unmanned systems capability from the ground up for them. In the United States, we are working with top of the DoD, Joint Rapid Critical Capability Acquisition Cell, Assistant Secretary of Defense for Cyber and Electronic Warfare. And a couple of days ago, I was at the Army National Guard yearly conference where I spoke in front of an audience of 4,000 military officers. So we are also now engaging with the National Guard and the US military for a training program to bring them up to speed of what is happening in the spectrum and to prepare this US military modernization and overhaul in here. And since I'm a veteran from the Ukrainian military, we are still very close with Kiev. We still collaborate. We are still up to date on the latest developments, what is happening on the battlefield. And yeah, we're having so much traction from governments and industry that it's becoming really hard to handle for our team. And that's why we're here to raise our seed round, $2 million, in order to be able to expand and to better serve all of our customers and everybody who is waiting for our technology. Thank you.
Thank you, Jack. Maybe a question in regards to your competitive landscape. Can you explain a little bit who you're up against and how you compare to your competitors?
So, like I said earlier, we ditched everything, you know, about conventional military radios, frequency hopping, and all of those things. We had to really reinvent radio from the ground up of how we do communications in an otherwise denied environment. So there is really nothing out there that comes even close to the way our radios work. And we are the only ones I'm aware of so far that had a 100% success rate of maintaining communications in an otherwise denied environment.
Thank you.
Thank you.
And I think with that,